In Africa, there are 4 countries facing serious trouble, possibly even full-blown disaster. Those are Egypt, Libya, Chad, and Sudan. That doesn't sound surprising at all, since most nations on this continent are dealing with extreme hardships. Food is scarce, infrastructure is underdeveloped, crime rates are high, industry's weak, and the biggest problem of all, African countries are in a never-ending water crisis. These 4 countries are some of the ones suffering the most from the water crisis on this dry continent, but they're making an effort to deal with it. And to some degree, it's actually working. Their plan looks like this: to take tons of sand out of the Sahara and pump water from an underground reservoir. Sounds easy, but it's not. Let's figure out why. Here's Mount Uenat, a mountain so captivating it could put anyone in a trance. It stands right on the border of 3 countries at the same time: Libya, Egypt, and Sudan, and Chad isn't too far off either. The place is full of ancient rock drawings that help scientists understand just how developed cattle breeding was in the Sahara long ago, meaning that the vast and unforgiving desert was once alive. Even now, if you check from a satellite, you can see green spots scattered there. Yes, right in the middle of the same blazing hot desert. Quite a long way from the Nile, the main water source that could at least make some kind of farming possible, right? And any other water source is also hundreds of miles away. The eastern part of the Sahara is dry, obviously. I mean, it's a desert. Are they ever wet? But the spot where Egypt set up its green circles has conditions that are just insanely bad. Researchers call the area hyper-arid, which makes perfect sense. Hardly any rain falls from the sky all year. On top of that, you've got winds that blow with nothing to stop them for one simple reason: there are no mountains or forests. After all, we're talking about a desert here, and to make things worse, sand plus wind equals sandstorms. You get the idea. There shouldn't be any greenery at all because the conditions are totally wrong for it. Still, there are circles here, almost 1,930 square miles of green circles. They're not just there for the show, they're used to grow crops right in the middle of a desert that most people try to avoid. And if you're wondering why they chose circles in the desert, the answer's simple. Such figures are obtained as a result of circular or center pivot irrigation. They set up this kind of system at a specific spot. It spins around its axis, spraying water, and that's how irrigation happens. The crops grow, getting their water from each of these systems, and that's how the green circles appear. When it comes to the massive circular fields in the Sahara, they mainly grow wheat here, something Egypt desperately needs right now, and in huge amounts too. According to a report from one of the companies involved in center pivot irrigation in this area, they managed to produce 40,000 tons of this vital resource in 2014. The main question is how? Where did they get the water to grow tens of thousands of tons of crops in an extremely dry desert, especially considering the sheer scale of the plantations, which means an enormous amount of water is needed? Where does it all come from? And here's the answer. The water comes straight from under all these circles. There are about 400 wells on the farmland, with another 250 still under construction. The wells that are already up and running give farmers plenty of fresh water for irrigation, and there are plans to keep expanding the area, which means they'll need to draw up to 660 to 792 billions of gallons a year. Moving further east across Egypt, we see more green circles, more farmland in the middle of the desert, and to be precise, this is the Toshka project. Here, the Egyptians are definitely trying to grow a huge amount of wheat, transforming dry desert lands for this purpose. Yes, there's fresh water in the lakes, which provides a resource for growing this valuable crop. However, in some places, the authorities consider wells the most preferred option. So as of 2017, the Egyptians had finished building 1,100 wells in various locations, some of which were part of the Toshka project. And there are countless such places all over Egypt. In some areas, desert circles and farmland of different shapes are supplied through canals, while in others it's so difficult to bring in the necessary infrastructure that they rely on underground water. The lack of the right farming equipment doesn't stop people in this case. Many private individuals just dig a well and then water all their crops without control. Why not, if the water's right under their feet? For all these reasons, Egypt annually pumps out about 435 billion gallons of water through holes in the ground. Now let's move to neighboring Libya. It's a country with lots of sand and dry areas. Actually, it's an understatement. It's got a whole lot of sand and drought. Look, red means hot and dry. Almost the entire country on this map is red. Do you see why it's hard to find words to describe the dry and desert-like nature of Libya? Now look here, this is also Libya. Here are the same green circles we've already seen in Egypt. Plus, there's a huge amount of other plantings. Everything that stands out in color from the surrounding sand is farmland. Yep, right in the dry areas of the same Sahara. In the vicinity of Tripoli, the capital of Libya, where the conditions aren't as horrible but fertility isn't exactly great either, the situation is pretty much the same. Only the scale is different. Literally every square mile is planted with something. Where does the water come from? Well, from the same place as in Egypt, from underground. Back in the last century, under Gaddafi's leadership, Libya started implementing a project called the Great Man-Made River. This is the largest underground pipe network in the world. Imagine the Libyans laid 1,750 miles of artificial water routes under the sands of the Sahara. Water flows through them from wells, more than 1,300 in total, and most of them are over 1,600 feet deep. The mind-blowing pipe lengths aren't the only thing that'll leave you amazed when you learn about this project. Around 1.7 billion gallons of fresh water flow through these waterways every day. It's literally what keeps the whole country and all the agricultural land alive. Sudan and Chad, which are nearby, also pump underground water. Yes, the scale is much smaller, but they still take water from beneath the earth because farming needs to be done, and the dry areas don't have other sources of water. So countries are actively pumping water from underground. For this opportunity, we should thank, first of all, those who invented pumps and wells, and secondly, geological and other processes constantly happening on our planet. The thing is, Africa and the Sahara used to look completely different. Scientists don't agree on what kind of landscape one could see in these dry places if we had the chance to go back in time. However, one of the main opinions is that during the Quaternary period, that is, over the last 2.6 million years, the Sahara was a region where much higher humidity was observed. Overall, trees, grass, rain, probably all of this was on the territory of the desert instead of the sands we see now. The moisture that entered the desert area was deposited and settled in sandstone formations. Then the climate changed, local conditions changed, geological processes took place. Voila! Modern man now has a desert, and nothing is left of what was there before. Almost nothing. The thing is, all that water that's built up over thousands of years hasn't gone anywhere. It's still somewhere under the African sands. Scientists call it the Nubian aquifer. They haven't pinpointed its exact location, though. According to some studies, the aquifer covers a smaller area under certain countries, while others show a larger area. However, everyone agrees that the underground water reservoir is definitely present in 4 countries, and scientists also all agree that it's the largest underground water reservoir on our planet. There are 39 quadrillion gallons of water there. It's hard to imagine such volumes, but we'll try. Look, take the Great Lakes of North America, for example. The total volume of water in them is about 6 quadrillion gallons. That means just under 4 African countries are sitting on a little more than 7 Great Lakes. If we compare within Africa itself, there's, for example, the Nile. The amount of water under the sands is roughly equal to 500 years of Egypt's main river's flow. Can you imagine how happy the countries are that sit on top of the Nubian aquifer? You can see all that excitement in what we've already discussed today. The active pumping of underground water for desert greening, drinking, and pretty much anything. However, despite the huge reserves, there's a big problem. An aquifer is actually a collection of water that can replenish itself. Precipitation, rivers, lakes, all the water that somehow gets to the ground can soak in and thus reach the water-bearing layer. So if you don't take more water than comes in, it's basically an endless water source. But with the Nubian water-bearing layer, it's different. It's limited by layers of shale and clay, which act as barriers to the vertical movement of water. This prevents the liquid falling on the ground from reaching the aquifer. Besides, as we've already mentioned, these aquifers are replenished by rainfall. In this regard, the Nubian groundwater's really unlucky because it's located in Africa, actually in the driest part of the continent, so there's simply nothing to replenish it with. No replenishment plus endless extraction means inevitable depletion in the future, and this means that all 4 countries will be left without a large portion of agriculture on their lands. To give you an idea of how critical the loss of the Nubian aquifer will be, let's put it this way. As of 2023, 7.3 million people lived in Libya. The vast majority of the population relies on domestic agriculture. Yes, including all those circles and other plantings in the sand. And here comes the scariest fact in the current context. 98.72% of Libya's irrigation needs are met by groundwater. Its disappearance will lead to a collapse. Yes, there's an incredible amount of water in the Nubian aquifer. Libya, which pumps almost 634 billion gallons a year, will take many, many years to fully deplete the underground water. But when we add Egypt's irrigation projects, and don't forget Sudan and Chad, on top of that, countries will surely keep pushing forward and tapping into the Nubian aquifer. For instance, Egypt, one of the main users of this water, is now actively working with other countries. In 2022, Canal Sugar, a company from the UAE, announced that it was starting to operate a sugar plant in Egypt. Not just any plant, but the biggest one in the world. For $400 million, the Emirati company built a facility that produces 18,000 tons of sugar a day. That much product was produced right after the launch as part of the preparation to reach full production capacity. Once it's up and running at full capacity, the plant will be able to produce around 1 million tons of sugar per year. In addition, the company's focused on growing wheat, corn, and chickpeas, strategic crops for Egypt, which is highly dependent on them and currently in great need of them. As for sugar, the initiative from the UAE will help reduce the sugar production consumption gap in Egypt by 75%, which currently stands at 1.1 million tons per year. The new plant will also help replace imports worth $900 million a year and will allow for the export of byproducts worth up to $120 million over the same period. They even created the world's largest sugar storage with capacity of 417,000 tons, 1,500 jobs right at the factory, and employment for 50,000 farmers and other indirect workers. What does the Nubian aquifer have to do with it? Well, look, the factory was built in the desert, and water has to come from somewhere. That's why Canal Sugar decided to pump groundwater, of course, from that very aquifer. As the company stated, to produce 1 million tons of sugar per year, it's necessary to develop and cultivate more than 286 square miles of desert land, which will require a huge amount of water. This kind of project is unique, of course, but in Egypt, there will be many other factories and farms popping up, all focused on increasing the production of various crops for the country, as well as making a profit. And all of them will be taking groundwater, because the Nile is already at its limit. Now let's take a look at neighboring Chad. It's a country that all other nations taking water from the Nubian aquifer should really pay attention to. There's a lake in Chad with a rather original name, Chad. Back in 1963, its area reached 9,600 square miles. That's about the same as Lake Erie in Canada and the USA, which also spans roughly that size. By the way, right now, this body of water holds 11th place in the ranking of the world's largest lakes. Do you realize how much water there was in Chad? By 2003, the lake looked like this. Over time, things didn't get any better, because by 2024, Lake Chad had taken on an even more miserable appearance. The reason is that around 1970, the local authorities decided to pump more water out, which led to a huge number of projects aimed at conserving water resources in the rivers that feed the lake. As a result, from 1970 to 1990, the average annual flow from the two local rivers was only 55% of what it used to be. By the 1980s, the amount of water coming in had dropped to just 30%. By that point, the situation had seriously hit the local population because fish catches had dropped and there was less water for farming. As a result, according to the UN, in 2018, out of the 30 million people living in the Lake Chad Basin, 10.7 million needed humanitarian aid just to survive. The situation's grim, so experts thought, why not refill Lake Chad using the Congo River? It had taken artificial waterway 1,500 miles long and cost between $50 and $60 billion. The idea is good, but there's a simpler option. It appeared in news reports in 2018. Yes, the replenishment of Lake Chad from the Nubian aquifer. The thing is, part of it lies directly beneath the formation of the lake in its basin. Those who promote this idea say Libya's been taking this underground water through its 1,500-mile pipe for many years, but we don't need to do anything for this because the distance between the lake and the Nubian aquifer is only 1,600 feet below. No one knows how seriously Chad and other countries will approach this idea, but if it happens, the aquifer will lose a huge amount of water. So if countries keep increasing the amount of water they're taking, serious problems are ahead in the near future. It's good that Libya, Egypt, Chad, and Sudan started talking about this issue back in the last decade. In 2013, countries gathered at a conference of the International Atomic Energy Agency and signed an agreement on joint management of a shared aquifer. Specifically, it includes the foundation for coordinated collective actions to manage water reserves. For example, it outlines the legal and political reforms needed to address key transboundary issues affecting the Nubian aquifer. The agreement doesn't directly mention reducing water consumption, but it emphasizes optimizing water use and preventing excessive extraction. This is exactly what Egypt's working on right now. The country has a 20-year project to renovate irrigation canals throughout the country, and in 2022, the authorities announced that it was about one-third finished. Around 4,000 canals have been lined out of the total. In addition, the project includes improving water quality and building desalination facilities. The benefits of modernization are obvious. Desalination stations can directly reduce the use of groundwater. Lined channels will allow less water to be lost, meaning less need for extraction. The same goes for improving water quality. It'll prevent situations where polluted water is replaced by another. Sudan's also contributing to saving the Nubian aquifer from depletion. Initially, of course, the country wasn't focused on saving underground water, but on something else. In Sudan, 40% of households lack access to basic water services, 67% don't have access to basic sanitation, and 75% don't have access to basic hygiene. That's why a program was launched with the World Bank's involvement, which at least partially will help improve the situation. However, Sudan doesn't forget about underground waters, which still hold great value for the country. There's a project aimed at boosting resilience and water security by improving the management of underground waters. It's hard to say what exactly is meant by this, but one can say that any change in the current use of the Nubian aquifer is a good decision, which, while it won't stop its depletion, will at least push it back to a later date.